move to the next presenter, which is Dr. Mahdi Mubarok from the Forest Products Department of the Faculty of Forestry and Environment, IPB University. Dr. Mubarok actually is also the International Academy of Wood Science PhD Award for 2020. And I think that his presentation entitled Valorization of Beech Wood through the Development of Innovative and Environmentally Friendly Chemical Modification Treatments is based on partially on his PhD. So Dr. Mubarok, the floor is yours.
Good morning, everyone. It is an honor for me to join in this World Day Symposium, and because besides it is the first time for me to join in, and my great thankfulness goes to the organizer of this World Day Symposium, and also to the International Academy of Wood Science Committee that has brought me in. In this presentation, the topic that I'm going to provide is about my PhD work with the title is the Valorization of Beech Wood through development of innovative and environmentally friendly chemical modification treatment, which was supervised by Professor Philippe Girardin, Professor Holger Minitz, and Professor Stéphane Dumarsais. This graphical abstract shows a simple illustration of the project goal in this version. So basically, we modified European beech, known for its low dimensional stability and poor biological durability, combined with low concentration of the chemical and combined with thermal modification to generate a modified wood owning better dimensional stability and biological durability. So the outline of this presentation is divided into 5 sections, including introduction, and then research part 1, studying the wood modification based on screening treatment using glycerol, polyglycerol, and maleic anhydride. And then research part 2, studying the upscaling trial based on the better treatment in part 1, and then treatment in open or in closed system. And then research part 3, studying the wood modification based on in situ polyesterification of sorbitol and citric acid. And the last will be ended with conclusion and perspective. According to the Global Forest Resource Assessment in 2015, the total forest area in Europe reached 1 billion hectares, with the increasing annual rate reached 80,000 hectares per year in the 1990s. Since 1990, among this huge abundance, one of the most commercial hardwood species in Europe is European beech, or Fagus sylvatica. This species covers for about 12 million hectares of the territory in the West and Central Europe, and it was called as the most successful Central European species. This species, known for its good enough in mechanical properties and workability, has been used for various applications. Unfortunately, besides its huge abundance, with some of them still underexploited in the nature, its low dimensional stability and poor biological durability limit its utilization, especially for exterior conditions. Based on these drawbacks, research on beech wood still interesting to investigate for its properties improvement. Numerous research has been performed, and some of them has been applied in industrial scale, including the use of wood preservatives and or biocides such as creosote, pentachlorophenol, SEQ, or triazole, etc. However, due to the increasing environmental concerns since the last decade, these techniques are gradually limited or even restricted in the future. Based on this environmental issue, a well-known wood modification treatment, including thermal treatment and chemical modification, would still getting much interest in the future. Based on this thermal modification, this technique can improve dimensional stability and decay properties of the modified wood, but the challenge for its low termite resistant properties and degradation of mechanical properties still under investigation. On the other hand, chemical modification, including impregnation of the reactive chemical into the wood, this technique is believed can improve wood properties to the desired wood characteristic. However, the challenge for its high cost of the process and handling of the chemical during process still need to take into account. Based on this limitation, our general research objective in this Fall Beech project was to find other alternative for wood modification to improve dimensional stability and biological durability of European beech, which we divided into two groups based on the chemical use. The first group was based on the phenylic glycerol and phenylic polyglycerol derivatives, and which we further divided into two sections. The first section was based on thermo and mill chemical modification, the combination between thermal modification with a low concentration of the chemical impregnated into the wood to reduce the chemical cost or the quantity of the chemical. And then the second section was based on the thermochemical modification treated in an open or enclosed system, and we did upscaling trials in this part too. And then the last group was based on the modification based on in situ polyesterification of sorbitol and citric acid. For the research part one, the work was performed in Nancy, France, with the objective was to find other alternative for wood modification through a combination between thermal treatment with low concentration of the chemical to reduce cost of the chemical based on the phenylic derivative of glycerol or polyglycerol. And then for this modification, we prepare the additive solution based on 10% additive solution based on polyglycerol maleate, glycerol maleate, polyglycerol metacrylate, glycerol metacrylate, and then polyglycerol metacrylate maleate, glycerol metacrylate maleate, and the last was based on the malic anhydride in a single form. And this solution was then impregnated into the wood with vacuum pressure impregnation process, and then the impregnated wood were then conditioned at room temperature to reduce the excessive solution, and then thermally modified at 150, 200, or 220 degrees Celsius for 20 hours under inert condition. And then the modified wood were then analyzed with various parameter analysis after conditioning. The parameter analysis that we conduct was dimensional stability, the general properties of wood for modified wood, such as dimensional stability, biological durability, physical properties, mechanical properties, chemical properties. Detailed result of this modification will be presented by request. So we directly go to the conclusion in this screening test. So we conclude that the combination between thermal treatment with low concentration of the chemical impregnated into the wood can improve dimensional stability and biological durability of the modified of untreated wood or thermally modified wood. From this study, the synergistic effect was found or were observed at 200 or 220 degrees Celsius. And among the additive that we used was malic anhydride-based additive such as polyglycerol maleate, glycerol maleate, and so on, presented better improvement than others. As a comparison between additive treated wood versus thermally modified wood versus untreated wood, it shows that dimensional stability, decay resistant, and thermite resistant properties of additive treated wood were higher than thermally modified wood or untreated wood, while the mechanical properties were lower than thermally modified wood or untreated wood at 200 degrees Celsius. But at 220 degrees Celsius, their mechanical properties were similar with the thermally modified wood, at this temperature, the thermally modified wood was already decay resistant. Unsatisfied with the termite resistant properties, unsatisfied with the termite resistant result from this laboratory test, we did field test study at the Arboretum IPB University, Bogor, Indonesia, with some selected additive based on their ECM synthesis, chemical costs, and wood properties, modified wood properties. So we selected polyglycerol maleate and glycerol maleate at 10 and 40%, while the temperature was made 180, 200, or 220 degrees Celsius. The additional temperature of 180 degrees Celsius was performed to prove the superiority of the treatment at 200 or 220 degrees Celsius. As a comparison, the untreated wood or thermally modified wood at the same temperature was also performed for this purpose. And on the field test side, we found that the Macrothermis gilfushagen was the dominant termite on the field. And this is the sample set underground for 347 days or almost 1 year. And after field test study and cleaning of the sample, we found it shows that the beech wood treated at 220 degrees Celsius was heavily attacked by the termite, while the additive treated wood at the cured at the same temperature were still in good condition. From this field test study, we found that the wood control at 103 or 180 or 100 or 200 degrees Celsius were completely devoured by the termite, while the wood control at 220 degrees Celsius were heavily attacked by the termite. On the other hand, the additive treated wood cured at 200 or 220 degrees Celsius presented very low mass loss value, indicating that their biological durability were excellent at this temperature. From this for this research part 1, we conclude that the combination between low concentration of the chemical and thermal modification can improve dimensional stability and biological durability of modified wood. And among the additive used, polyglycer malate and glycer malate at 10% concentration, followed with curing at 200 or 220 degrees Celsius, was considered as the better treatment. And however, due to the acidic properties of the additive and higher curing temperature, the mechanical properties, especially MOE or MOR of the additive treated wood, decreased considerably, and equivalent with the wood control treated at 220 degrees Celsius. For the research part 2, the work was performed in Göttingen with the objective was as follows: upscaling trials of the better treatment in part 1, and then the upscaling trials of the treatment in open heating in open system or under heat pressurizing in closed system. The additional modification of the heat pressurized in closed system was performed to lower the curing temperature or to reduce the or to shorten the curing process. This is a simple procedure during upscaling process in open systems. So we, as usual, we prepare the additive solution and then we impregnate it into the wood, and then with bigger sample size with vacuum and pressure impregnation process. And then we did aging process for complete impregnation process. And then the impregnated wood were then conditioned until moisture content of less than 30%. And then we did curing at 120 or 150 degrees Celsius. With a similar impregnation process, the wood modified under HPS was also performed at different curing temperature and pressure for 3 hours, and then followed with the curing with the drying at 103 degrees Celsius. And then the modified wood were then analyzed with very experimental analysis. And then, interestingly, this is the appearance of the sample treated under OHT or HPS process, showing that the wood modified under HPS here with the additive addition presented a darker color than the wood modified under OHT. From this first impression, we thought that the wood modified under HPS would have better dimensional stability and biological durability. From 31 upscaling treatment, we selected certain treatment. There were 15 treatment that would have a good result against soft rot in Göttingen or field tested in Indonesia. However, due to a better result from the soft rot test, as they classified as durable to very durable wood, so we directly go to the field test study to convince their biological durability. So at the same site in Indonesia, we did a field test study batch 2 for 320 days, 28 days, almost 1 year for this treatment. And then after this treatment, after this field test study, we found that a certain treatment have already devoured by the termite completely, or but others treatments still in a good condition. From this field test study, we found that treatment under open heating in open system at 150 degrees Celsius with higher curing with higher additive concentration, or treatment at 220 degrees Celsius with lower concentration of the additive presented better biological durability than others. Unfortunately, due to acidic properties of the additive and curing temperature, their mechanical properties, especially their work to maximum load in bending, presented very far lower than untreated wood. However, the MOE or MOR value were slightly decreased for MOE or specific were almost similar with the untreated wood, but for their MOR slightly decreased from the untreated wood. This modification means that there was big changes in the wood structural component or wood structural arrangement from this modification. From this research part 2, we conclude that almost all treatment can be implemented in the biggest sample size, and then upscaling process under OSC in an open system remains still a promising technique for chemical impregnated wood, presenting better in biological durability and slightly better in mechanical properties than treatment under heat pressurized steam in closed system. However, due to the acidic properties and higher curing process, mechanical properties especially work to maximum load in bending of all modified wood decreased considerably. For the research part 3, the work was performed in Göttingen dominantly and Nancy, with the objective was to find the optimum condition for in situ polyesterification of sorbitol and citric acid in the application on beech wood. This is a chemical structure of citric acid and sorbitol used for this modification, which were based on environmentally friendly chemical and biosource. For this modification, we varied source concentration into 10, 20, 30, and 55% in aqueous solution. And then we impregnated into the wood with vacuum pressure impregnation process. And then we did a conditioning at room temperature until moisture content of less than 30%. And then we did oven drying with increased temperature. And then we did curing at 140 or 160 degrees Celsius. And then the modified wood were then analyzed with various parameter analysis after conditioning at room temperature. And this is the chemical reaction between sorbitol and citric acid, showing formation of the sorcha biopolyester at the end of the reaction at high curing temperature. From various sorcha concentration, we found that the sorcha 30% at 150 degrees Celsius curing condition or 160 degrees Celsius curing condition presented very better biological durability against decay, as they classified as very durable wood against white rot or brown rot fungi. While for the soft rot resistant test, only sorcha 30% cured at 160 degrees Celsius was classified as very durable wood. And this is the appearance of the wood modified with sorcha at 150 degrees Celsius, 140 degrees Celsius, or 160 degrees Celsius, compared with the untreated wood or thermally modified wood at the same temperature. From this appearance, we can see that the wood modified at 160 degrees Celsius was darker in color, indicating that the wood modification was heavily or greatly influenced at this temperature. From this research part 3, we conclude that the optimum concentration for this modification was 30%. At this concentration, the weight percent gain, weight loss due to leaching, and the acidity of the modified wood at 140 degrees Celsius were higher at 160 degrees Celsius, while their dimensional stability and structural modification were lower than at 160 degrees Celsius. On the other hand, the biological durability and mechanical properties for both treatment were almost similar. As a general conclusion for the study, we conclude that the various treatment can improve significantly dimensional stability and biological durability of European beech. However, due to the acidic properties of the additive and the curing temperature, the reduction in mechanical properties remains still the limitation in this treatment. From this study, some suggested treatment for their application with or without contact with the soil can be prescribed here. And as a perspective from this study or for the future research can be listed as follows: implementing the selected treatment for fast-growing wood species, which we has already testified for fast-growing wood species in Indonesia, and then conducting glowability tests and coating properties, and performing field test study for source modified wood, and investigating other chemical on very low acidic properties, neutral or slightly basic condition. Before I ended this presentation, I would like to acknowledge my supervisor, my Professor Philip Gerarda, Professor Holger Milis, and Professor Stefan Dumarste, and my examinator, Dr. Lina Lunes, and Professor Joris van Akker, and my CIRAD colleagues, IPB University colleague, PhD committee member, Göttingen College, Nancy College, Lab of Asylum of Excellence R, my old professor, PhD college technician, and administrative crew in Nancy Göttingen, Epinal, Indonesia, and International Academy of Wood Science Committee, and to all of you attending this World Wood Day Symposium. Thank you very much for your attention.
Thank you, Dr. Mubarok. Any questions?
It's a little bit fast.
Okay, so yeah, that was a lot of material to for people to digest, I guess. That was very good project and a lot of combinations. Yes, but yes, well, thank you and congratulations again for winning the. Professor Richter has a question, I guess.
Yes, please.
You need to. Okay, yes. Go ahead.
Yes, thank you for the very impressive research we have done, and congratulations also for your PhD award. I think this was well awarded, and a lot of work you have invested in your research. Of course, these combinative treatments are of course not known in all the details, but I would like to see or learn your feeling. Of course, if you try to combine classical or impregnation with a pressure process, as you have done it also with very new and maybe more environmentally friendly preservatives or treatment molecules, and then combine it with the temperature process. How much improved is the combined efficiency compared to the isolated efficiency? So would industry really take over this combined effort when, of course, there is an improvement, but maybe the improvement is not so impressive that a single treatment or a single process would also at least fulfill the needed improvements. What is your feeling in this?
Thank you very much for the comment and or questions. So basically, if we modified wood with the preservative and thermal treatment, I think the double advantage for example, their decay durability with higher temperature for due to thermal modification can improve, while their termite properties, termite durability properties will be more advantage with the addition of the preservatives. Of course, the admitted preservatives in Europe. So combination between preservative and thermal modification is a good option as well. That can be tried for the future research, maybe as a perspective. That's good. Thank you.
Thank you
for my opinions.
Okay, thank you.